Hey everyone, and welcome back to the podcast. I'm Mark, and as usual, I'm really excited about what we're talking about today.
And I'm Jenny, always up for exploring something new. Mark, you've been dropping hints all week. What's the big reveal?
All right. So I've been on this deep dive into the Electron-Ion Collider, the EIC, and, well, it's going to drastically change how we see, like, the tiniest times parts of everything.
Whoa, that's a big claim. I've heard of it, but I'm a bit hazy on the details. What times an electron-ion collider exactly?
Picture it as, like, the ultimate microscope. But instead of cells, we're peering into the stuff times psi times atoms, quarks and gluons. They're going to smash electrons into ions. Basically atoms with some electrons missing.
So, crashing tiny things into other tiny things? What's the goal there?
The goal is to see the aftermath. When these particles collide at super high speeds, they show their inner structure and how they work together. Think of it like smashing two watches together to examine the gears, only asterisk way times more complex and at a subatomic scale.
Okay, I think I'm getting it. But why is this EIC so important? We've had other particle colliders, right?
Yeah, like the Large Hadron Collider. But the EIC is distinct. It's the first to collide times polarized times electrons with protons. It is a little like lining up spinning tops in the same way before they smash together. We get to observe how the spin is distributed inside a proton.
Polarized. That's the key, huh? What's the big deal about the spin?
It's a big deal. There's this proton spin crisis. Basically, scientists found out that the spins of the quarks inside a proton don't times add up to the proton's total spin. The numbers just, don't make sense.
That sounds a bit unsettling. Like there's something fundamental we're missing.
Precisely. And the EIC is built to crack this mystery. By carefully measuring the spins of both quarks and gluons, the particles that, like, glue quarks together, we can hopefully find where that missing spin is hiding.
So it's like tracking down the missing pieces of a cosmic jigsaw puzzle.
Exactly. And it goes beyond just spin. The EIC will also give us insights into the color glass condensate, this weird state of matter where gluons are packed really tightly.
Color glass condensate? That sounds like something straight out of a science fiction story.
It kinda is. It's a theoretical state of matter at really high energies, and the EIC will give us a chance to observe it, directly.
Okay, my head is starting to spin, but in a good way, this sounds super complex. How will they even, times construct times this thing?
That's another impressive part. The technology is, impressive. They're aiming for a luminosity of 10 to the power of 34. That's a measure of how many collisions occur every second.
Wow. So more collisions equal more data, right?
Exactly. And more data means more accurate measurements. Like having a super high-res camera to capture the smallest details.
And I heard something about virtual reality being used?
Oh yeah, that's the neat part. Scientists are creating VR tools, like Virtue, to visualize the collision data. Imagine stepping times side times the collision, seeing particles fly around in 3D. Pretty cool, huh?
That's wild. It's like going from reading about it to actually times being times there.
Right? And it's not just for looks. VR can help scientists find patterns and unusual things that might be missed in regular data analysis.
So it might actually lead to new breakthroughs?
It's possible, yeah. It's a completely different way of interacting with data.
This project has a significant cost, though, right? I think I remember it being in the billions.
It is. Somewhere between $1.6 and $2.6 billion. But we need to consider the long-term gains. And it's a global collaboration.
That's true. Sharing the cost and the knowledge across several countries.
And some people wonder if that money could be better spent, on more immediate problems.
Yeah, that's a valid concern. It's always a balancing act, isn't it? Funding fundamental research versus addressing, pressing societal needs.
Definitely. But the tech they're creating for the EIC, the detectors, the data tools, those could have uses in other areas, like medicine or computers.
Ah, the good old unintended consequences. Or maybe time intended times consequences that go beyond the initial goal.
Exactly. And, there's also the argument about whether there are other times ways to explain these phenomena without such a huge experiment.
Like alternative theories that don't require smashing particles together at quite this scale?
Yeah. It is important to explore every avenue. But so far, this seems to be the best way.
Makes sense. So, what are the scientists hoping to learn, aside from all the spin stuff?
The hope is that the EIC will give us a better understanding of the strong force and how matter is created. Really get down to the basics.
It really is pushing the boundaries of what we know. I'm excited to see what they discover.
Me too, Jenny. The EIC is a testament to human curiosity. It shows our desire to explore the universe at the most fundamental level. This is going to be a thrilling journey.
Thanks for explaining it all, Mark. I feel like I can finally understand this amazing project. And to our listeners, thanks for joining us on this dive into the Electron-Ion Collider. We'll be back next week with more tech adventures.
See you then.